Okay. Now we're up and running here. Sorry about the delay, some technical problems. Welcome to the second lecture of the intro to research on web technologies. Today we'll go a bit further than we did last time and look into the specifications that we talked about and the technologies that we talked about, if you remember that. Some fundamental standards of the web, like HTTP, HTML, CSS, and JavaScript, and the standardization process. We'll also talk about current technologies, HTML5, CSS Level 3, ECMAScript 5, and standards in progress, HTML 5.1 and 5.2, CSS Level 4, and ECMAScript 2015. It changed the name from ECMAScript 6 to 2015 last year. No, maybe they're not published yet. You'll find them if you click on the link for the slides last time. You'll find them by replacing 01 with 02 instead on the URL. So it's not harder than that. Okay? That worked? Yes. And also, probably use the two first sessions on these theoretical topics, and then we'll have a workshop in the last session, the last 45 minutes or so. And you can, if you want to, of course, I encourage you to do so. You can work on this workshop after today as well, during this week. But it's not mandatory. It's only a workshop. It's up to you. If you remember, we have two mandatory assignments. I will inform you about them later on, the dates and the assignments. But these workshops are not mandatory, but of course you should do them. Yes. Fundamental standards. HTTP. Are there any HTTP experts here? Have you worked a lot on the protocol, not on the protocol, but with the protocol HTTP? In some REST APIs, for example? Yeah. So you will relate many of those things you have implemented upon REST. You will relate to the actual specification of HTTP. So HTTP, the Hypertext Transfer Protocol, that's an application layer protocol in OSIML. It's a request-response protocol, and it's designed as that from the beginning to enforce the client-server model. So that means that you, as a client, do a request, and then, of course, you get a response back. Either an error response or an OK response of some kind. It's originally a stateless protocol. It says here that each request-response cycle are completely independent. Anyone want to elaborate that on stateless protocols? What does that actually mean?
Maybe that all the information that the server needs to know needs to be sent in the request.
Yeah.
The server's not storing any like personal information like the sessions or.
Yeah. So originally it was stateless, but then cookies were introduced. E.g., you know, I suppose you know sessions in different languages like Java or PHP or Node or different kind of types of languages. You handle cookies or sessions. And these sessions are handled by cookies. What does that mean? How do they do this? How do you use cookies in this communication on HTTP to handle sessions in, for example, Java?
Cookies are stored in browser, and on each request, browser sends all cookies that belong to this domain as headers in HTTP request, and server using these headers can handle this state like user ID, for example, or something.
So you can either the server can send a cookie to the client on the first request, for example. Maybe session cookie. That's only an identification of a session. So it sends a session cookie to the client. The client stores this cookie. A cookie has a lifetime. If the lifetime is not set, then the cookie's lifetime is over when the browser is closed. Okay, so the cookie is stored on the client side, and then whenever the client is doing another request, it sends this cookie with the request. And then if the server wants to respond something or more information, it sends the cookie back as well. So you keep this cookie going back and forth during this communication. And this means that the server can have states for example, data. If you want to log in to some kind of service, it uses this cookie or this session cookie to know that you are logged in, you are authorized to do that and that and that. And this is an identification for that. More or less a token, you can say. You can also use cookies to store information on the client side. You can set a cookie with some kind of value, and then you know that the client has this information. You can use this on the client side, and you can use it on the server side. Okay, so states may be maintained using cookies, e.g. session cookies. There are many names for different types of cookies, but the principles are more or less the same. You have tracking cookies, for example. You see this underscore GA cookie in a request, for example, in the HTTP request. This is Google Analytics setting cookie, for example. And Facebook is setting cookies and so on and so on. These are typical tracking cookies. Okay, so we have a client. It does an HTTP request. A typical client is a browser, for example, but it can be anything. It could be curl on your command line. It could be some kind of robot indexing your site or something like that. It does an HTTP request, and it sends. It's divided into two. You have the request header, and you have the request body. The request body is sometimes also called the payload. Have you heard that? Payload of the HTTP request? Yeah. That can be, for example, form parameters or any other data. And this must be specified with a limit type. In HTTP, you have different methods. These methods are, of course, documented and specified. And depending on the different methods that you use, the server should apply to this. So, whenever you're entering an address in your web browser and you click enter, what kind of HTTP method is the browser using? Get, yeah. So HTTP GET, that's to request data. So typically all the requests that you do by entering an address in your address line in the browser, that's a GET request. Then you have POST requests to post data. So you can set up, for example, forms in HTML to either post or get data. The best thing is always doing a post. But you can actually send data with both the get and post. How do you send data with the get request?
URL. Put it in the body.
No, that's post request. Yeah.
URL.
Yeah. So you use parameters in your URL. Okay. So that's URL encoded data. URL encoded parameters with values. So let's say that we implement the same form in HTML with the same attributes or values, parameters, and you do a GET request. Then you get a new URL encoded. You get your data URL encoded in your address line. You see the actual data that you're sending. But if you do a similar form, you implement a similar form and you set it up to do post requests instead. How did it handle this data then? How did it send this data? Same data in form.
It's in the body.
Yeah. It's part of it. It's what we call a payload of the HTTP request. But if you look into these kind of requests, for example, in the Chrome Inspector, for example, you can see that the same URL encoding of the data is being done in the payload as it is done in the address line. So it's using the same kind of standard for encoding these data. So it's more or less sent in the same way. Instead of having it in the address line, you send it as part of the payload or the body of the HTTP request. You can see an example of a GET request here. Can you see that in the back? So, what address are we actually getting here? Well, full URL.
We have header post. That probably means that we are accessing the domain www.html5rocks.com.
Yeah.
And the path of the query is /n/.
Yeah. So we're actually requesting the address www.html5rocks.com/n/. So you see that after the HTTP request method, you denote the address that you're accessing, but the host of the address is a specific parameter in the HTTP request. And the post example here is an example of a post to myformapi.asp on somehost.com, and it passes two parameters as part of the payload. Okay, let's look at HTTP request headers. Host, that's the address of host from URL. User agent identifies the web browser. So the web browser, for example, or any other client can identify themselves to the server. And accept header, types of data the browser accepts. So you can tell the server that you accept these different meme types of data. And then the server can respond to that. Okay, you only accept HTML. I respond HTML. You can also set the types of encoding that this client accepts, like gzip, deflate, etc. So this client accepts zip data, compressed response. For example, an Apache web server will conform to these accept headers, like accept encoding. If your client says that it can receive gzip data, it passes that back to the client. As long as you haven't overridden that with some kind of configuration. If it doesn't accept gzip data, it sends raw data back, the entire text. And here you also see the cookies that probably are already set by a server on this domain. It passes these cookies to the server in the request as well. Okay, so this is a full example of a GET request. Let's look at an actual GET request then. This is a newspaper, Norwegian newspaper. We can look at, if you have the plugin Web Developer Toolbar, I think it is, in Chrome, you can inspect the request that the browser is doing. So do you see request headers here somewhere? We can look at the response headers then. I can go on with HTTP responses. Okay. Responses also follow the same pattern. You have header and body, and this is typical for many protocols. So this is nothing new. In the headers you have metadata, and in the response body you have the data. But in responses, HTTP responses, you also have error codes. Every code between 100 and 200 is informational codes. And between 200 and 300 you have success codes. So typically, most of the requests that you're doing, you get a response with an HTTP 200 OK, like in the example there. Sometimes you have errors in your client, for example, and this is between 400 and 500. And this is the error codes that you typically use in your web application. Something goes wrong there. For example, 400 bad request, or 401 unauthorized, or 404. So that is probably that is quite common. Resource not found. And then you have server errors, typically in the 500 range. For example, 500 internal server error. I think that's what the web servers like Nginx or Apache or something like that sends whenever it can't resolve the host, for example, on your server. 503, service unavailable. And these are also the codes that you typically use in REST APIs. For example, if some client or user isn't authorized to request or to receive some resource, you can send 401. Or in your REST API, if you you can't find the resource that is requested, then you send 404 not found. Then you can utilize this in your client. So REST APIs is very much built upon the architecture of HTTP. You'll see that later on when we talk about web services as well. So these are HTTP response headers. For example, cache control. This is control of caching. So you can say to your client that you want to cache this resource, and you want to cache it for some amount of time, for example. Yes. So let's look at the response headers that we got from Dag. Here is a typical, the typical meta information of an HTTP response. Maybe I should. Can you see it now? Yep. Date, the content encoding. This is a gzipped resource. So the client has to unzip it and then interpret it. Age, that's related to caching. And you have a lot of X dash attributes. Do you know what those are?
They're like more the developer of the API, for example, can specify their own headers, and they are normally prefixed with an X dash.
Yeah, exactly. So, for example, Varnish, that's a reverse proxy or a caching service, and it provides also its own attributes, and it prefixes it with X. Okay, connection keep alive, what does that mean?
keeps alive the connection so it can send more requests through the same connection.
On what level?
TCP?
So you can tell the client to keep the TCP connection alive so that you want to many different, or you won't connect to the server many times during a conversation if you pass requests back and forth quite rapidly. So then it utilizes this connection that's already established and it communicates upon that. Vary, that's for reverse proxies like Varnish. Say that, okay, these parameters have more or less states. So you have to cache different different versions of the response based on these headers. You have cache control, transfer encoding, different types. Content type, text, HTML. So if you pass other types of documents, then you have other content type headers. So this is only the header of the response. You see? After this, after 200 OK, you will have the body or the payload. Sorry, the body of the response. Either HTML or JSON, for example, or something. Depends. Any questions?
I have a question regarding user agents. For example, if I'm in Firefox, it says I am using Firefox on this operating system. But if I, for example, go to Chrome or Edge or some other browser, there's a mix of many different technologies, and it's very interesting. For example, in Edge, I see Mozilla, Apple WebKit, Chrome, and Safari in the user agent, and I'm pretty sure that Microsoft haven't based their browser on all of those technologies. Why did they do that?
I can't answer that specifically, actually.
I know the answer.
Yeah.
It's because in the old days of the web community, so the browser had different implementations of stuff, and web developers started adding, like, if you're using this user agent, display this web page.
Yeah.
And they had the best experience on, for example, the new Firefox.
Yeah.
And people started adopting that into their own user agents to get the Firefox experience on all their browsers.
Yeah. Because you had a lot of server software that was actually rendering or passing, responding differently based on what kind of user agent you sent. So that's the reason for that. Okay. That was HTTP. So we go on to HTML. I won't talk much about the basics of HTML. You'll have to look into that yourself. But we'll look into some aspects of it. So, as we already talked about, HTML is a markup language for documents. When a browser is receiving an HTML document, talked about this last time as well, it starts building a DOM, an HTML DOM. Suppose you remember what a DOM was now. That's document object model. It's a model an object-oriented model of the document that it received. So it more or less maps the HTML structure to a node structure with objects. We say that it's a high-level API. What does that mean, do you think? There aren't any actual specifications of a JavaScript DOM, for example. The interface in JavaScript isn't specified in place. But the DOM specification itself, from which you see, that's only a specification of the interfaces and the structures that you build with your DOM. So it says what kind of attributes the object should have. For example, an HTML div element or any other objects or classes of objects. Tells what kind of attributes they should have and what kind of methods or functions it should expose. See? So that means that the specification is quite general. And it's up to a browser render, for example, to implement this in their JavaScript interpreter. And let the JavaScript interpreter expose this same interface to you whenever you're programming JavaScript. And that also goes for DOM implementations in Java or C# or PHP as well. These are native implementations based on the generalized API that is specified from VGC. Let's look at the DOM specification. We'll look at a lot of specification as we go on. Let's see. Maybe I went to the wrong resource here now. Yes. Yes. Yeah. For example, DOM exceptions. This is how they specify DOM exceptions, for example. That's a class. It have some const attributes, index size error, DOM string size error, etc. We can look at other classes as well. This is the interface document, specified as a node. So they specify the inheritance as well, because different objects inherit from others. You have a read-only attribute document type, read-only attribute DOM implementation. Yeah. And you have a lot of methods as well. Create element, create document fragment, create text node. And if you try this on the document element in, for example, your web browser, you will see that these methods are exposed exactly the same way, of course. And if you have a DOM interpreter in PHP as well, they will be exposed in the same way. So it's a very generalized specification. Okay? Cross-platform and language independent. a DOM tree that is HTML elements represented as nodes in an organized tree structure. And it provides a convention for representing, traversing, and interacting with the HTML objects. You can use some kind of tools as well if you want to inspect your DOM in your web browser, for example. You have DOM inspector in Chrome and in Firefox, and typically every browser. Okay. Any questions to HTML and HTML DOM? Have you worked a lot with DOM in any language? Server implementations on DOM? Because you can parse HTML documents or XML documents into server or application languages like C# and Java as well, and handle them, traverse them, and manipulate them as you would have done in JavaScript. So it's quite useful because if you interpret, for example, let's say that you interpret an HTML document in PHP with your DOM implementation in PHP, you can manipulate this as you do in JavaScript, and then you can save it afterwards and serialize it as an HTML document. You see? So that's quite useful. What are the downsides, do you think, by handling documents like this?
Performance.
Yeah, performance. You're using a lot of resources to build this document object model, or this tree of objects. So you get a quite resource demanding application. The browsers handle this very good. If you have quite deep nested, and then I mean very deep nested HTML DOMs in your web browser as well, you will see that you can maybe actually feel that it performs better than it would have with a lighter DOM. You can also see it in performance indexes or and different other measurements as well. Yes, let's move on to CSS, cascading style sheets. In CSS, typically your structure of a CSS element is you have a style selector and you have a property for that selector. So what elements are we selecting here? Yes. Yes, we're selecting H1, but all H1s?
No.
No.
Only with the ID.
No, not exactly.
The header elements that reside under the div with the
Yeah.
header ID.
All H1s that are descendants of an element with ID header. You see? So if we had the div ID equals header, and underneath there we have an H1, or an H1 maybe 2 or 3 steps down, further down in the tree, all those would have been selected by this selector. So then all these rules, max width, 160 pixels, overflow, hidden, etc., apply to those that are part of this rule, this style selector. Okay, examples of different selectors. The first is quite easy. All the elements, span elements in your document are selected by that rule. The second is all the span elements with class myClass. In span elements or any other element in HTML, you have the attribute class. Class equals myClass, for example. You can have several different classes on one element. This is all the spans that have one class that is called myClass. In the third example, we have the element span with class myClass and an attribute foo that equals bar. So you can say that we have span with attribute class equals myClass and attribute foo equals bar would be selected by this. This rule I have actually misunderstood a lot in earlier years in my development career. Span nth child 6. Anybody want to explain that one?
Well, you're specifying the index of the child element under span, the descendants.
Ah, almost.
I've never seen that before.
It selects spans, first of all. But it selects all the spans that are the 6th child of its descendant. You see? No, sorry, of its ancestor. Okay, and you have also these pseudo classes like hover. I suppose many of you have used that, and that triggers when you have your mouse cursor over. So every span with class myClass, which are hovered with your mouse, are triggered. These rules are triggered for that. So these are pseudo classes. Okay, but there may be rules, different rules. For example, max width. Max width 160 pixels. That could be applied to one element in several different rules. So how do we prioritize? Let's say that we have one rule that sets max width 100 pixels and another rule max width 200 pixels. How do you prioritize the rules? Which one should actually apply to this element? Then the browser have this CSS priority list. First of all, it prioritizes by importance, the importance of the rule. It prioritizes, second of all, rules that are inline. For example, in the HTML document, in the different HTML elements, you have this style attributes, and you can have style elements or style rules there as well. Then it prioritizes based on media type. Have you heard about CSS media queries? If you have tried to build responsive web applications or web pages, you have media queries that should apply to whenever the screen is 600 pixels or the screen is 1200 pixels. Fourth priority is user-defined CSS. Any examples of that? For example, if you have helper tools, like if you are visually impaired or something, maybe you have tools that give you better contrast on your viewing screen, for example. Then these tools can apply CSS rules to your web pages, so that is actually applied to your web page, and those are user-defined, for example. Number 5, selector specificity. What does that mean? Let's go back. There. What rule is most specific of these two? Second one, yes. Because it applies to fewer rules. You can also nest these, like you can have div, and then you have maybe an A with the class product, for example, and then you have span.myClass. So it depends on the hierarchy of these elements as well. So the more specific the rule is, the more the rule is prioritized.
But how to know
So,
which?
so this will be prioritized before this.
But how to know which rule is more specified? For example, the third and the fourth rule. If it's a fourth rule, would be span.myClass as well. Which one of them more specified?
Yeah, that's a good question, because that's a common problem. Because you can have complex rules that are prioritized differently between the browsers, but less now than for 5 years ago. So it's quite different. It's it's difficult to prioritize rules in this way, because this recommendation is so specific. Prioritize on rule specificity. That's quite hard. And then it prioritizes on rule order, in which order it is loaded by the browser. So rules in one CSS file that is loaded after another CSS file overrides the first CSS file. If it's the same rule, for example. Then parent inheritance. Then CSS property definition in HTML document, and last browser default, because all browsers are implemented with a default CSS set that have a basic styling of your H1 elements, for example. They aren't, it specifies the font size, for example, of the H1 elements. Yes. Let's see. I think we'll take a break now. I'm 10 minutes late as well, but we'll catch up. So, okay, let's start over again at 2:30. Okay, so 17 minutes break, and then we'll start over.
You could try to restart your computer or just turn it off, take out the power, and then take out the battery and just plug everything back in.